Chapter 6 The Luxury of Lead. A very different burial, also found in Maryland, has helped archaeologists decipher the story of a colonial family whose lives bore little resemblance to that of the boy found in the Levy Neck basement. This grave, excavated beneath the foundation of a chapel in St. Mary's City, turned out to be among colonial America's most unique resting places. As archaeologist Henry Miller explained, the chapel, a solid brick structure dedicated to Catholic worship, could not have been built anywhere else in the English-speaking world during colonial times. As the director of research at historic St. Mary's City, a recreation of a colonial settlement, Miller has spent years studying the unusual place Maryland holds in the religious history of the United States. Modern Americans know the United States as a nation of religious freedom. The Constitution protects the right of every individual to practice religion according to personal choice, not law. Centuries ago, however, the first English settlements in America did not allow this freedom, nor did England itself. By law, a branch of Christianity called the Church of England, also known as the Anglican Church, was the nation's official religion. Accordingly, most English people belonged to this church. Some, however, followed other religions, such as Roman Catholicism. Because the law forbade these religions, their followers often had to worship in secret to avoid being harassed, imprisoned, or even killed. It was against the law to build a Roman Catholic church in England or its colonies. The colony of Maryland was founded in 1634 by a man who was determined to create a safe haven for English Catholics. Cecil Calvert, also known as Lord Baltimore, received a charter from King Charles I to establish a colony on land purchased from the Yauco-Malco people. The new colony was named in honor of Queen Henrietta Maria, the Catholic wife of Charles I Calvert, also a Catholic, who advocated a principle called liberty of conscience, which permitted religious freedom for all Christians, though not the followers of other faiths. The colony's charter gave Calvert the authority to make liberty of conscience the official policy of Maryland, even though England did not allow this freedom. This permissive environment made Maryland unique in colonial times. As such, it attracted settlers of many Christian faiths, including Catholics. Among them was a group of priests who built a brick chapel in St. Mary's City in about 1667. The chapel served as a house of worship for many years, but in 1689, a revolution in the colony removed the Calvert family from power and ended religious freedom in Maryland. The government center was moved away from St. Mary's City, and in 1695, Providence, later renamed Annapolis, became the colony's new capital. In 1704, by government order, the chapel doors were locked forever. Later, Catholic priests dismantled its walls and carted the bricks away to be used elsewhere. Only the chapel's sturdy brick foundation, which lay beneath the surface of the ground, remained. Slowly, as years passed, more soil accumulated over the chapel's foundation. Farmers planted tobacco, corn, and beans in the soil. Eventually, all traces of the foundation were hidden from sight. In fact, almost all traces of St. Mary's City disappeared as well. The surface of the ground gave no hint that anyone had ever lived there. Nor did the historical record offer many helpful clues to Henry Miller and his team of scientists when they began their work during the early 1980s. There are no historical documents of the city, no maps, no good written descriptions, Miller explained. We had to rely on archaeology. Fortunately, careful scientific investigation proved to be enough. Miller, chief archaeologist Tim Riordan, and the many scientists who have worked with them since excavations began have found thousands of artifacts in the foundations of many of the settlement's buildings, including the brick chapel. They also found a large cemetery that surrounded the chapel's foundation. Their discoveries have revealed many details of 17th century colonial daily life and death, but one of the finds was as unique as the Maryland colony itself. A stupendous find. In the fall of 1990, Stephanie Bandy and Molly Quest, two archaeologists on Riordan's crew, were excavating inside the foundation of the St. Mary's brick chapel, beneath an area where the chapel's floor had been. When we scraped the subsoil, there was a detectable feature on the surface of it, but it wasn't a normal grave shaft. It was obviously bigger, Bandy recalled. Suddenly, her trowel hit something hard. "I think it's a big rock," she called to Tim Riordan. It wasn't long before she realized that she was mistaken. As soon as we exposed the edge of the object, we could tell it was shaped like a coffin, she recalled. As she cleared away more soil, the the team saw that the object wasn't made of wood. Bandy's discovery turned out to be something no one had expected: a metal coffin. Miller and Riordan weren't surprised that the team had found a grave inside the chapel. In England, burying the bodies of church members beneath the floor of a church or chapel was a common practice, especially among wealthy people. It cost more money to be buried inside the church than outside, so only the wealthy could afford such a luxury. With this knowledge in mind, before the excavation began, Miller and Riordan had asked geophysicist Bruce Bevan to survey the area with ground-penetrating radar, or GPR, a scientific technique used to detect and pinpoint the location of buried objects. Bevan dragged the GPR equipment across the land surface around and within the chapel's foundation. The equipment sent pulses of radio waves, waves made by electric and magnetic energy, into the ground. Solid objects buried beneath the surface reflect radio waves back towards the surface, much like the way a mirror reflects the rays of light from a flashlight. An antenna attached to the GPR equipment transmits the radio waves to a receiver. A computer translates them into a regular pattern of lines, called an echo, on a monitor. A solid buried object disrupts the pattern and creates a group of zigzagging lines. Although GPR cannot determine what a buried object is, Miller and Riordan hope to learn the extent of the chapel's foundation, and if any large objects lay buried beneath the floor. Indeed, the GPR echoes revealed a brick foundation that was 3 feet thick and that extended 5 feet under the ground, sufficiently massive to support a tall, permanent building. The foundation had been built in the shape of a cross, a symbol of Christianity often used for a church's foundation. The GPR also produced a mysterious echo beneath the chapel's floor. This echo, which came from an area in one of the arms of the cross, was even stronger than the foundation's echo. When Bandy began digging in that spot, she'd had no idea what to expect. A big rock was likely a possibility, but a metal coffin was not. Because the tip of Bandy's trowel had scraped the coffin and left a tiny mark, Miller and Riordan knew the coffin had to be made of a soft metal called lead. In England, only royalty or very wealthy people were buried in lead coffins. And in 17th century America, lead coffins were extremely rare. The person buried here must have been someone important. To prevent damage to the coffin, Bandy set aside her trowel. We used paintbrushes and even a pair of gloves to brush the last bit of the dirt off the top of the coffin, she recalled. Further excavation led to more surprises. 2 other lead coffins, one buried on each side of the first. One coffin was larger. The other was big enough only to hold a baby or a small child. Miller and Riordan could scarcely believe it. 3 lead coffins. The entire team was eager to find out what the coffins contained. But they had to wait, because the lead coffins appeared to have been undisturbed for centuries. They could provide historians and scientists with an unprecedented opportunity to learn more about 17th century people, their burial customs, and even their environment. For example, if the coffins had been tightly sealed when they were buried and had remained so, they might still contain 17th century air. Scientists could analyze that air and compare it to modern air to discover how the atmosphere had changed over the centuries. To preserve every bit of evidence that the site might contain, Miller and Riordan had to make a detailed excavation plan, which would require a great deal of thought and cooperation of many historians and scientists. To leave the coffins unprotected during that time was unthinkable. Television stations and newspapers had widely reported the team's amazing find. We were concerned about someone sneaking onto the field and digging down to the coffins, explained Tim Riordan. To keep them safe, we exposed half of the top of the coffins and a couple of inches down on each side to make sure that it was just 3 coffins that were there. We photographed and mapped them and then filled the grave shaft back in, explained Stephanie Bandy. Then they covered the backfilled grave shaft with sheets of tin topped with a thick layer of soil. With the discovery securely protected, Riordan and Miller started planning Project Lead Coffin, a scientific study that would examine the coffins and their contents. They assembled a team of almost 100 members, including historians, many types of scientists, medical personnel, and photographers. Over the next 2 years, as the team researched and developed their strategy, historians found a useful clue. a document that described the opening of the only other lead coffin ever found in North America. These two coffins had been buried in an underground vault in the cemetery at Trinity Episcopal Church, also located in St. Mary's City. In 1799, a group of medical students had entered the vault and opened the coffin to study the remains within. Modern historians believe the coffins contained the remains of Sir Lionel Copley, the first royal governor of Maryland, and his wife Anne. Both had died in 1693. With permissions from Trinity Episcopal Church, the team reopened the Copley vault and examined the two coffins and their contents. They noted how the coffins had been constructed, gathered forensic evidence, and took samples for later isotope analyses that enabled them to confirm the identities of the occupants. This information helped the team to develop a scientifically thorough strategy for excavating and opening the three recently discovered lead coffins. By August 1992, every step of the process had been meticulously planned. Each scientist had a specific role and knew when to collect the samples he or she needed from the grave shaft, the soil, and the coffins. We had to ensure that one scientist's evidence collection didn't mess up the data for another, recalled Miller. Project Lead Coffin was about to move into action. Wrapped in lead. The archaeologists began the excavation by removing the backfilled soil to expose the head ends of the three coffins. They were interested not just in the coffins, but also in the wall of undisturbed soil left behind after the backfill had been removed. This soil became the object of investigation of geologist Gerald Johnson. Johnson specializes in stratigraphy, a branch of geology that deals with understanding how soil and rock layers and the features found within them are arranged. It explains the order in which layers and features form and how they change when the soil is disturbed. Stratigraphy can provide critical information about the timing and nature of such changes, helping archaeologists to analyze their findings. The stratigraphy of the undisturbed wall of soil told Johnson an interesting story. He clearly saw the outline of a grave shaft that had been dug wide enough for the two large coffins to be buried in it side by side and at the same depth. That meant that they had been buried at the same time, but changes in the soil's color and texture also told Johnson that sometime after that burial, this large grave shaft had been disturbed. The shape of the disturbed area cut down directly through the soil that had been used to fill in the large shaft. The tiny coffin lay at the bottom of the disturbed area. Thus, Johnson could tell that this tiny coffin had been buried after the two large ones. The next step was to attempt to retrieve an air sample from the coffins, a tricky undertaking. Opening a coffin would immediately corrupt the air it contained. Without the correct preparation, a drill or any other instrument inserted into the coffin would break the coffin's airtight seal and let the modern air enter the coffin. Nor could the team drill a hole into a random part of the coffin to obtain a sample. The tool might damage the human remains inside. Before proceeding further, the team had to know exactly how these coffins were constructed and where the remains lay. In other words, they needed a way to see inside the coffins without opening them. An X-ray is one of the first tools that scientists use in such a situation. In this case, that wouldn't be possible because conventional X-rays can't penetrate lead. Fortunately, the team had anticipated and solved this problem during their planning period by building a small lead coffin for testing purposes. Nuclear physicist Mark Moore experimented with techniques similar to X-rays to find one that could see through lead. The experiments showed that another type of ray, called a gamma ray, easily penetrated the experimental coffin's lead sides. Like X-rays, gamma rays can be used to create an image. Based on successful trials with the experimental coffin, the team decided to examine the project's coffins with this technique. In small, measured amounts, gamma rays are helpful in treating certain kinds of cancer, but uncontrolled amounts are very dangerous. They can cause serious illness. To protect people from the risk, Maryland state inspectors required the team to build a protective wall around the coffins before they used the gamma rays. The safety wall contained more than 600 large sacks of sand. Next, the team put special photographic paper along one side of the head end of each coffin. The instrument that produced the gamma rays was placed on the other side. It directed a short burst of gamma rays towards each coffin. Different materials, for example, lead, wood, or bone, absorb different amounts of gamma rays. Lead absorbs a lot of gamma rays. As the coffin absorbed the rays, the lead appeared as a light area on the gamma ray image. but like a person's bone shone brightly on an X-ray image. Air, on the other hand, absorbs few gamma rays. The rays that pass through air-filled spaces inside the coffin's dark created dark areas on the image. The images revealed that each set of remains was actually contained in two coffins. The outer lead coffin had been constructed around an inner coffin made of wood. The remains lay inside the wood coffins. Unfortunately, the images also showed that the small and medium-sized coffins did not appear to be sealed tightly shut. In fact, the team could see that the medium-sized coffin rope handles had rotted, leaving holes that had permitted air to enter the coffin. However, the largest coffin seemed to be tightly sealed. The team hoped that it meant that it might contain preserved 17th century air. The team decided to sample the air from the large coffin using a special tool, a drill with an air hose attached, that Mark Moore designed. The gamma ray image had revealed an empty area in this coffin, so the team knew that the drilling into that area wouldn't damage the contents. But sampling the coffin air was tricky. Even the tiniest hole drilled into the coffin would let modern air inside and contaminate the coffin air. Again, the team was ready with a plan. Using Moore's drill and hose tool, they slowly bored part way into the lead and stopped. The scientists used a vacuum pump to remove all the air from the hose. When the hose was completely air-free, they resumed drilling the rest of the way into the coffin. To make sure the coffin hose was removing only uncontaminated coffin air, the team needed a way to detect any changes in air pressure. Such a change would indicate that the coffin's airtight seal had been broken and that outside air was flowing into the coffin. Think of sucking liquid from a juice box. As you drink, you vacuum juice air from the box. That reduces the air pressure inside the box. The pressure of the air on the outside of the box becomes greater than the air pressure inside, causing the sides of the box to collapse inward. If you then stuck a pin in the box, outside air would flow in through the hole, raising the air pressure inside the box. That increase would be strong enough to push the sides of the box back to their normal positions. To measure the air pressure inside the coffin, the scientists connected an air pressure gauge to the air hose. The monitor on the gauge would reflect any changes in the coffin's air pressure. As the team removed air from the coffin, the monitor remained at a constant level, indicating that no modern air from outside the coffin was seeping in. This supported the team's belief that the coffin was airtight. They transferred coffin air into sealed containers which were sent to a laboratory for analysis. For a while, the air pressure in the coffin remained stable, but eventually the seal loosened. The coffin held the seal for about 3 hours, then it started letting go, said Miller. The pressure gauge monitor showed that outside air, containing oxygen, was seeping in. Oxygen gas reacts with many substances, including human remains. In 1799, when the medical students unsealed Anne Copley's coffin, they reported that her body, hair, and burial clothing were still well preserved. But as soon as the students opened her coffin, oxygen reacted with their flesh, hair, and clothing, causing ruinous results. The scientists reported that within a few hours, the cloth and flesh had crumbled to bits. 200 years later, when the project-led coffins team reopened the coffin, no traces of fabric remained. Of course, Miller and Riordan had no intention of allowing the remains inside their lead coffins to disintegrate. During their preparations, they had developed a solution to the oxygen problem. First, the team stopped the inflowing gas. The next step was to replace the oxygen with an inert gas called argon. Inert gases do not react with other substances, so they don't contribute to decomposition. While the coffins had laid buried below the surface, their contents were the same temperature as the soil surrounding them, about 50 to 60 degrees Fahrenheit. As the team excavated, however, the lights they used for visibility had heated the air, causing an air temperature increase around the grave shaft of about 10 degrees Fahrenheit. That increase would have also raised the temperature of the argon. Even though argon is inert, the additional warmth from the gas might have posed a threat to the remains. Again, the team was ready with the solution, but this one didn't require any cutting-edge technology. They simply filled a picnic cooler with ice. Before they pumped the argon gas into the coffins, they channeled it through the cooler, chilling it to the same temperature as the soil that had surrounded the coffins. Through this method, the team protected the remains in all three coffins from further decomposition. The last step before they removed the soil wall that still surrounded the foot ends of the three coffins was to make a record called a soil peel. Gerald Johnson treated the wall with a sticky substance called resin. Then he smoothed a layer of cheesecloth over the resin, covering the entire exposed soil surface. He applied a coat of resin to the cloth and topped that with another layer of cloth. After the resin dried, Johnson peeled the cloth from the wall. The soil that had formed the face of the wall was stuck to the resin, creating an exact copy of the soil layers. The soil peel was stored in the St. Mary's City Laboratory so that it could be consulted if further questions arose concerning the stratigraphy of the grave. To the clean room. In a typical excavation, the next step after exposing remains is to undertake an in situ examination. But nothing was typical about this situation. The size of the grave shaft and the conditions at the site made an in situ examination of the coffin's contents impossible. The coffins would have to be removed from the grave before they were opened. The team prepared for this step by testing the strength of each coffin to ensure that it could be moved safely. The coffins were scanned with infrared light, a type of light that allows scientists to see how metal retains and loses heat. After heating the coffin surfaces slightly, the scientists watched the metal cool under the infrared light. Areas that contain cracks cool at a different rate than undamaged metal, making the cracks readily visible under infrared light. If the coffin contained cracks, the lifting process could place enough stress on the lead to widen them. The coffins might break into pieces. Fortunately, the infrared light revealed no cracks. Lifting the lead coffins, the largest weighed almost 1,500 pounds, was a formidable task. Mathematicians used special instruments to calculate the thickness of the lead. From those calculations, they determined each coffin's weight. To raise the coffin in the safest possible way, the team decided to lift them on metal plates, starting with the baby's coffin. Positioned alongside it, a hydraulic jack. Positioned alongside it, a hydraulic jack gently pushed a rectangular plate into the soil a few inches below the coffin. The layer of soil between the plate and the coffin served as a cushion. The jack slowly pulled the little coffin away from the medium-sized coffin. A mini crane lifted the plate and coffin up and out of the grave shaft. As soon as each coffin had been safely lifted from the grave shaft, it was taken to a clean room, a spotlessly clean laboratory area. The clean room at the site was a U.S. Army surgical field tent that had been specifically set up in the field near the chapel's foundation. Inside the tent, Doug Owsley, Carrie Brolhide, archaeologists, conservators, and medical personnel analyzed and sampled the remains for further scientific analysis. What they found amazed and puzzled them.